So I'm doing this not as the high quality as I normally do here, so bear with me on this. So I'm writing on the screen with ThinkHub, and I'm going to be able to show you all the work that we're doing. But notice the breakdown that I have is still the replacement, the case, and the rotation. So in the previous video you saw me kind of set that up as exactly what I'm going to be doing with you on this. So in the overall setup here, we have numbers already of the 55, 99, 109, all bunch of stuff, and I'm going to demonstrate how that works out. So first, every new node is going to be inserted into the tree in a regular binary search tree fashion using the Plinko to get down to the right location. That new node is also going to be red no matter what. So if our tree is completely empty, our first node is 55 and there's nothing to, well, it's red. The thing I have to check for is to see if I have two reds connected. If I don't have two reds connected, great. I don't have to do a darn thing. I don't. But which one of the cases does it still work out with and still have to worry about is case number 4, which basically just makes sure that it turns to black when everything is done. So after our rotation, which really there's no rotation in this, our tree will look like this. So in our next phase, we're going to be adding 99 to our tree. And again, well, frankly, just phase 1 is just placement. So where's the 99 going to be placed in a binary search tree? Well, 99 is greater than 55. So we're going to go ahead and put it to the right. Again, it's going to be red. And again, we check to see if, frankly, we have any issues. There's no two reds connected at all, so fine. So in this case, it's really case number 4 again, or 0, depending on if you want to just make it black again. But we still have the same exact tree that we had. There's no real issues. That's our next phase. So for our next number, it's going to be 109. So 109 is going to be placed into a tree that we've already got. We have 55, 99. Again, that's the placement phase, this first block. So where will 109 be placed? Well, we got our first problem. 109 is greater than 99. And we do have two reds together. So now we've got a problem. I'm also going to do one other thing here real quick, because this will probably come up here. Is I'm going to put, let's see here, we have a crazy uncle in that spot. So now, just for a moment, pause and see which one of the cases this will actually match up with, and see what we need to do, and I'll demonstrate that here in a minute. So hopefully you figured out that this is going to be case number 3. And case number 3 basically has us do a rotation like this, so that 55 is going to drop, 99 will pop up, and 109 will come with it, and then we do some coloring with this. So in reality, everything that's going to be done here is going to be, what color do I have here? Black, okay. When I'm totally said and done here, it's going to be 99, and then with our 55 and 109. So that's how this tree is going to look after we do our rotation. So again, just following the case 3 that we had on our paper, we did rotate to the left in this example, and we made some color changes, just like it says in case number 3, and that's our finalized tree at the end of it. Now, is this a binary search tree? Yep. Do we have two reds in a row? Nope. We're in good shape. So here's our next number, being 45. Well, 45, we know we're going to have an issue because, frankly, all the kids are red. And again, the newest node that we're going to drop into the tree is also going to be red. So we got bad news. We're going to have to do a rotation eventually. So where does 45 drop? Again, this is the placement phase. Let's make sure we get that right first. 45 will be less than 55. So we're going to put 45 right here. All right. Now I'm going to start labeling everything a little bit more. And this is X, this is the parent, grandparent. grandparent, and this time we have a red uncle. So which one of the cases matches this, you need to take a look at. So what we're going to have is at least a case number 1. Now remember, in case number 1, which I went over previously with you, is that we'll have to double check this node after we make the changes to it. So in reality, there's really going to be 2 actions that happen with this, not just one by itself. So what's going to happen first is that we're going to go ahead and blackify the parent and the uncle, and we're going to make the grandparent red. So that's what's going to happen next, and you'll see that here in a second. So now I'm not done yet because, well, frankly, I have to double check this guy to make sure that we don't have any connections to it being red because we just changed it to red. Now we got lucky because it happens to be the root, so there's nothing above it. So in reality, now I'm going to do case 0 and go ahead and just make that node into black because there's, well, again, that's the last step after we've done all the cases, is to make sure that the root is black, and that's what you'll see here in a second. So what you see me doing is basically finishing out that last case, making the root black, and there's our finalized tree with that. And there's how kind of balanced it is so far. It's really small, but at least it's pretty near balanced here. But again, notice that it did have to do 2 cases on that one. Again, one's always going to be that one where we have to double check after we've made this into a red, which is the grandparent, and we got to check from there up every time. This one was easy because it happened to be the root, but we'll leave it at that. And on to the next. So now our next number is going to be 65. So what do I do with the 65? Well, again, placement phase. We're going to go ahead and put the 65 is less than 99. It's greater than 55. So that's where we're going to put our 65. And do we have any issues with having 2 red nodes together? The answer is no. So yay! So case number 4 is really we don't do a darn thing. So it's going to be the exact same tree in our final phase because we really didn't have to change a thing, thank goodness, because again, there's no 2 reds in a row. Alright, for the next one we're going to add 78 to the pile here. So where's 78 going to go? Less than 99, greater than 55, and greater than 65. So again, new node is going to be red, and that is 78, yep. Do we have an issue? Yep, you can see right there when 2 of them are together. So if we have an issue, what you're going to see me do instantly is then go ahead and label everything. That's going to be X, it's going to be parent, it's going to be grandparent, and then we do have an uncle. So go ahead and check your sheets on which case this is going to match and what our rotation is going to be. So our first case that this matches is 1. So that means that we're going to blackify the uncle and the parent and make this into a red, and then we'll move on from there. So here's a tree after we've done our case 1 on it. And again, now, because this was the grandparent, this is the one that we will check now from there on up. But here's the funny part. Do we have any issues of 2 reds in a row? The answer is no. So we got lucky. That's actually going to be case number 4, where there really isn't any change to make because we don't have any 2 reds in a row. So we actually go case 4 and then no change. So that got easy on that one. So here's our next number, is 123. So let's figure out placement phase where things end up here. So 123 is greater than 99. 123 is greater than 109. So it should be red here. Well, let me make sure I got the right color here. So this should be 123. And do we have any issues? Nope, there's no 2 reds connected, so great, we got lucky. And that will be case number 4, and there's no real change. So that one was easy. Alright, so before I start into 102, let's just do a check. Check number 1. Is it a binary search tree? Yep. Number 2, at every leaf, does it take the same number of black nodes to get to the root? And the answer is, yep. So we're in great shape so far. So most likely we're right. So that's good news. So next we're going to put in 102. So where's 102 going to go? Again, placement phase. 102 is greater than 99. It's less than 109. So sweet. We got lucky. And that's going to be 102. And do we have any issues with 2 reds in a row? The answer is no. So that's awesome. That's again case number 4, no change. Alright, so next is 104. So where is 104 going to get placed in the placement phase? And we'll worry about everything else here in a minute. 104 is greater than 99, less than 109, greater than 102. But I know this is going to happen. We're going to have 2 reds in a row. So that's 104 here. And then I'm going to go ahead and label everything. Because again, I only label, notice, only when I know I have 2 reds in a row. So, X, parent, grandparent, uncle. Figure out which case this belongs to, and we'll go from there. So again, this is case 1, which is also bad news because that means we got to follow it up with when we change the grandparent. And this is going to have this become red. Whoops. That's going to become red. And then these 2 are going to become black. So you'll see that's tree here in a moment. So here's our new tree. Notice I didn't do any rotations yet, just colorization more than anything else with the Blackify. But now, as you know, after 1, I've got to double check what we've got with our new X being, which was the grandparent. Do we have 2 reds in a row? Nope. So I get lucky again. This doesn't always happen, by the way. And really, I mean, honestly, we don't change anything, and that's case number 4. And that really, there's no change. So no change. So here's our last number for this demonstration, and that's 107. So 107, the placement phase, we do that again. It's going to be a red. 99, 107 is greater than 99. 107 is less than 109. 107 is greater than 102, and it's greater than 104. So we go ahead and put our new red node right here. It's going to be 107. So now we know we have an issue because frankly we got 2 reds in a row. So I'm going to go ahead and label everybody. So that's our X. That is our parent. This is our grandparent. And yeah, I'm going to put in that crazy uncle over here. Which you notice I always do in a box just to make sure that you understand this is a crazy uncle here. So whoops. Let me do that in a different color here. That's an uncle. So now we need to figure out which case this fits with and do our possible rotation. So thankfully this is a rotation, but it also terminates once we're done with that rotation, and that's going to be case number 3. And I'll show you what the ending tree looks like here in a moment. So just like it says in case 3, this rotated to the left. The parent became, well, got promoted, let's put it that way, and grandparent took a dive, and then X kind of came up with it. So notice the changes that we have over here for our final answer on getting everything done. Again, let's double check. 2 checks. Is it a binary search tree? The answer is yes. Number 2. Does it take the same number of black nodes from every leaf to get to the top root? And the answer is also yes. Matter of fact, it's kind of a nice, clean, well, tree, as in black, red, black level, red level. It's kind of funny how that worked out that way. It doesn't always work out that way, but it did in this case. So we have a very, very good tree. We've done our checks throughout the entire time. Make sure you understand we have our placement phase, what case we identified, and then what we had to do in order to do those cases and possible rotations to get to our finalized red-black tree.